GM, we're back with the second episode of our SNL series with Akshay. Akshay here is a senior smart contract auditor who has gone through and hacked into a lot of smart contracts. But we'd like to hear about him from Akshay himself. Akshay would love to get a brief introduction about you.
Hey Sanket, firstly, thanks for having me. So yeah, I'm a smart contract auditor, security researcher currently. I do like public audits, bug bounties, and private audits. In the past, I've done smart contract development work for various DeFi projects. So yeah, I've been pretty busy last 3, 4 years building and doing Web3 stuff. And again,
Wonderful.
glad to be here.
Yeah. Thank you for agreeing to do this, man. And really great to have you here. So, would like to actually, dive right into it with the first question. I hope that's okay.
Yeah, yeah, sure.
Okay. So, there are a lot of hacks that are happening with, hackers getting smarter and smarter. But this one particular hack that's become extremely popular nowadays, which is called the flash loan attack. So, can you please elaborate on what this hack is and what would be some of the strategies that probably you would use to mitigate this hack? Should you see something like this in a contract?
Yeah, sure. So regarding flash loans, I think about it like a feature, not a bug or a vulnerability. So flash loan is just a sudden influx of capital in your protocol, right? So it can happen via whales as well. Guys holding millions of dollars in their wallets. So flash loan is just giving that opportunity to everyone. Anyone can instantly borrow a decent amount of money and put it in your protocol. So that's not a new thing. It can already happen via uh, individual accounts. So the thing a protocol can do to prevent that kind of hacks is to prepare for a sudden influx of capital. So you can like put some guards, like some caps on the influx, like you won't be allowing more than $1 million entering your system. So that kind of thing. And generally you should be like uh, the protocol should be okay with anyone depositing some amount of money in your protocol. So at the end of the day, that is what you are building for, right? For people to deploy money in your project. So you should not try to run away from it, but try to uh, prevent techniques to handle it so that your protocol doesn't break when someone suddenly deposits $10 million in your project. So yeah.
Understood. Got it. So, since we're on the topic of recent hacks, frequently used hacks, another hack that we as an auditing company have also seen a lot is the front running. So, is it possible that you can quickly help us understand what front running exactly is?
Yeah, so in public blockchains, everything is public. So anything you are about to do on the chain, your upcoming transaction can be seen by various actors, because the mempool for Ethereum is public. So anyone can see that you are about to swap some tokens, or you are about to add liquidity in that pool. So and after saying that, anyone can insert a transaction before your transaction, so which can manipulate some prices or do other stuff, due to which you can suffer some potential loss. So that is front running. uh, it generally happens in token swaps. I guess that's the most frequent one. And to mitigate that, most protocol have slippage limits. So every user who is swapping the tokens provides a value that I won't be accepting the output tokens which is less than X amount. So if the price deviates too much, your transaction will revert. So essentially, you are protected against more deviations. So this basically is front running.
Understood, understood. So, I mean, we talked about flash loans and we talked about front running. So, now coming on to a different type of attack vectors. So, if you think about a developer, right, who's probably building a DAO protocol. So, what are some of the attack vectors that such a developer should keep in mind while developing that particular protocol, so that when the protocol is live, the chances of the protocol getting hacked are very less.
Yep. So for the generic protocol thing, there are various kind of attacks, reentrancy, overflows, and all kind of stuff. So to prevent them, you can do security reviews, do bug bounties, and do internal security reviews where you can your team can try to break that contract, all those things. And regarding like the recent attacks that we have seen around governance, so governance attacks are also becoming mainstream nowadays, I guess. So they generally involves around like an attacker getting like admin rights of your protocol. So anything which can expose that kind of vulnerability, you should try to prevent that. So anything that gives attacker instant voting rights, that could be a bug. So if your protocol can give like 10 million tokens worth of voting rights to an attacker or just a simple user instantly, that's a bug. So what you can do is you can implement some delays between account acquiring tokens and giving him the rights to vote. So there could be a delay so that will prevent instant flash loan attacks, by which the attacker can get governance right. There could be other mitigation as well, but mostly they should be around like uh, preventing anyone from having instant access to your tokens or the overall governing rights.
Got it. Got it. So, my last question was about, DAO hacks. And a very popular DAO hacks that made the headlines for quite a while was the tornado DAO hack. So,
Yeah, yeah, yeah.
I mean, so probably would you like to shed some light on the analysis of how that hack happened, what that hack was all about, and what could have been done to prevent that?
Yeah, so the recent tornado attack, it was a governance attack where the attacker, got the governance rights of tornado. So what he did was he tried to like he like made a contract upgradable using the create and create two opcodes. So he like first presented a code which looked legitimate. The like the tornado governance like gave the rights to execute operation on that contract. And once that was done, at the last moment he like swapped that contract with the malicious one, which like had all the token mintings and other kind of stuff, due to which the attacker got the governance power of the protocol. So it was basically the upgrade of a legitimate contract to a malicious one using the create and create two opcodes and self destruct. I guess it is called metamorphism. Yeah, yeah, that's the word. So that was a bit like overview of that attack.
Got it. So,
Quite
I
a
mean,
interesting one, I guess.
yeah, I think one of the key aspects of this hack was the upgradability, as you mentioned. Is that right?
Yeah, yeah, but it was not like a general kind of upgradability, right?
Hmm.
Which the developers would have. wouldn't have allowed to be executed. It
Okay.
was a special case where you can self-destruct a code and then reinstantiate it
Mm.
with a different code. So it was like a quite interesting one and a clever one, I guess.
So is there something that they could have done to prevent this hack?
Yeah, they could have looked at the deployer accounts of that
Mm.
contract. So, anything which has self-destruct and is being deployed by another contract that can
Mm.
have this metamorphism thing. So, if that contracts was deployed, would have been deployed by an EOA, a
Mm.
user wallet, then this attack wouldn't have been possible.
Hmm. So I think deployment is a part that a lot of people, don't really take care of that well. So regarding the deployment, do you feel as an auditor there is an industry standard or maybe a checklist that everyone should have while deploying these contracts to ensure, that the contracts are deployed safely?
Yeah, sure. So firstly, the protocol owners should be aware that people could be monitoring your deployment scripts, your deployment transaction, and be prepared for getting front run or all kind of stuff that can happen as attackers know that you will be deploying a new contract. So just be aware of that. And things you can do to make those deployments safe are maybe like deploy from a new account every time. So if you use a single account for all of your deployments, so uh, you are giving hints to attackers that any transaction from this wallet will be a new uh, smart contract for our protocol. So they might be like trying to capture any value which can be held there. You can also like implement some validation scripts after your deployment. So, for example, if you 10 of your contracts get deployed via script, so you can add or create another script, which performs all the validations of those in those 10 contracts. So they can check that state A is correct, state B is correct, and contract X and contract Y are linked together. All those kind of stuff. The ownership of contracts is correctly initialized. All those things. A frequent attack that can be seen is front running the initializers of proxy contracts. So generally, what developers do is they deploy the proxy contract and then they initialize it in another transaction. So that second transaction can be front run. So anyone who front runs it can get the ownership right or any other potential advantage over your contract. So what is recommended is do the initialization in the same transaction as the deployment, so that you eliminate the opportunity to front run it. So those can be a quick quirks which you should be aware of or plan to mitigate them.
Got it. No, I think some pretty valuable insights on the deployment checklist that every protocol should kind of follow, regardless of the way that this structured. So coming back to the tornado now, and I know that you said that this was sort of a special case of upgradability, but we also feel as an auditing firm that upgradability is is probably a crucial factor for the syllabus of any budding smart contract developer. So, can you share the security aspect of upgradability through probably the perspective of any smart contract developer who's just learning to build contracts or maybe just getting into auditing? What is the crucial impact of upgradability, and what are the security implications that it might present for the protocol?
Yeah, sure. So generally, protocols implement upgradable contracts due to the reason that they might need some additional feature in the future, or they might encounter some bug in their contract, and to resolve that, they might need to make some code changes. So that's the reason the protocols prefer to have upgradable contracts. But and that is done you know, by implementing like proxy and implementation contracts, doing delegate calls from proxy to implementation contracts. That is like a bit of more technical things, but yeah, but also like these upgradability features also, have potential to introduce bugs in your contract. So, once you decides to upgrade from contract A to contract B, there could be a chances that a lot of things can go wrong in that upgrade. You might mess up the states of your previous contract. You might do some integration mistakes which can make your contracts unusable, or creates a bug which can which anyone can exploit. So these are the things that devs should be aware of. Generally, in my personal opinion, I am not a big fan of upgradability. I try to even with my clients, I try to recommend them to go with immutable contracts if it's possible. They can have some capital limits for their initial versions. Like they can go live with a contract which can only hold $500,000. So and if for 3 months that contract doesn't get hacked, they can remove that cap, and the contract can now handle any amount of fund, and it's is immutable now. So that kind of thing I generally recommend to protocols. But yep, some protocols need upgradable features, like generally like lending protocols. They like they are very change prone, so they might need to add more price oracles, more lending markets. Those are the things, those are kind of protocols which always, I guess, need upgradability, or like a scope for introduce changes to the code base. On the other hand, it's like AMMs, they can go immutable from day one, like the way Uniswap did. So yeah, I guess so. Having it or not, the upgradable feature also can uh, depend on the type of protocol you are implementing.
Got it. Got it. No, some pretty valuable insights, especially, I mean, I've also seen, I mean, a lot of projects using, immutable contracts and a lot of projects using upgradable contracts. And a lot of the hacks are based on the upgradability of contracts, especially for protocols that can work with immutable contracts, to be honest, but they still choose to go for upgradable contracts. But anyways, moving on, I mean, I think we all understand the importance of functional testing. But in the recent time, or maybe even from a while back, we've seen different types of testing, like fuzzing and invariant testing, right? So could you probably tell us, I mean, what these different types of testing are, in addition to functional testing, and what is the use, what is the scope of these type of tests and everything? Thank you.
Yeah, sure. So fuzzing tests are becoming quite popular recently. So I guess with the rise of Foundry, people are getting more aware about fuzz testing. So those are like tests where you test your contracts with different kinds of inputs, a different range of inputs. So you might have created a function which gets one uint value, and perform some operation on it. But in your test, you might have tested it against 2, 3, 10 inputs. But if you try to implement a first test, you can test it against like hundreds of or thousands of inputs, and be certain about the working of your function. So that's first testing. And invariant tests are also like test around your system where you know like define invariants of your protocol, that condition that always should hold true, and after every test you validate those conditions. So if you are lending market, you like did a supply transaction, and then you will test the invariant. You do a withdrawal transaction, then you test the invariant. So those kind of stuff. So, and yep, but these are getting quite popular, and developers should implement these. I guess for auditors as well, we also try to implement these kind of testing. I myself use fuzz uh, quite a times, especially with mathematical functions. So, I try to like fuzz them with different inputs. So just to verify that, it works as expected for a range of inputs, for a range of values. And I guess I have used it for like different kind of libraries as well, like elliptic cryptography libraries, or all mathematical libraries. So you always get certainty that the function or the that code segment is working as expected, as you might have tested against a large number of inputs. So that quite helps.
Got it. So, I mean, obviously, some great knowledge for all the auditors who are coming in and especially starting to use Foundry. But another thing I feel is getting very popular are automated tests nowadays. And I've talked to a lot of auditors personally, not to name them, but most auditors don't like these automated tools a lot. So what's your opinion on automated automated tools, and do you feel that these tools are sort of reliable, or do you feel that it goes against the better judgment of auditing companies to use these, or even protocols or projects to use these as their in-house tests?
Yeah, so I like don't use them a lot, but I know that they have some potential. So if you have recently seen Code Arena, for example, they have introduced bot races. So for every audit they do, they like run the bot races for 1 or 2 hours maybe. So any bug that is found in that race is considered as already known issue. So what happens is bots, these scripts can be very good at finding repeatable issues, right? So anything which can be like said as a low hanging fruit, that can be found with these scripts or these bots, these automated tools. So that can help you a lot if you are doing audits. Just so that any low hanging fruit that exists in low hanging bug that exists in that project, you can get it in few minutes or few hours, right? But the issue is these tools are, they report a lot of false positives. So anything which may seem like wrong but is actually right, so you get a lot of them. And to filter them out needs manual intervention, which can lead to like your time getting wasted. So most I guess most that's the reason most auditors doesn't use those tools. But yeah, I'd say they have some potential, and we'll see like a rise of these automated tools in the near future for auditing and for bug bounties, basically to secure the smart contract world.
For sure, for sure. I mean, obviously, completely agree with you. All tools have their use cases. We've been discussing tools for a while now, I think, but the one tool that everyone has, and probably, I mean, this is from a movie, of course, but the sharpest tool in the shed is your mind. So, as an auditor, what do you feel your mindset should be while auditing and looking for bugs? How do you use that tool to get into the mindset of a hacker and just try to break the contract and check for bugs and vulnerabilities? So, I mean, as a security professional, how should you begin with an audit, and what is the mindset of an auditor?
Yeah, so I can talk about like myself. whenever I start an audit, I always like go with the mindset that this protocol has high severity bugs, and it's my job to find them. So it doesn't matter if that protocol was developed by the best devs in the space, or it has like 10 audits by the best companies. But whenever I do audit, I go with that mindset that it has bugs, and I have to find them. And that like generally helps a lot, because it gives you the motivation to find any kind of bugs or anomalies that can exist in that protocol. uh, Regarding my process, I like always start with you know doing some quick scans of code and the protocol docs, just to understand what the protocol intends to do, and how they have implemented those specs in the contracts. So just to get that these are the 10 contracts, these are the functionalities, these are the the features of the protocol. I start with that, and then I go like deep in each contract and each function. I do manual review. For bug bounties, I generally don't do use any automated tools. But for like private audits, I use Slyther, and there are some other tools. There is a tool from C4 which I use to get low and gas findings. So yeah, that's the like motivation and process. And with every day of that audit, you get to know more about that protocol, and you can go deep into that code base, and try out some exotic scenarios and all kind of stuff that generally gives you a medium or high at least.
Understood. So that's very interesting. And I think, I mean, it's very important to have the right mindset before you perform any activity to get the maximum results out of it, to get the maximum output out of
Yeah,
any
yeah,
activity.
exactly.
So yeah, so I think we're a little short on time, and this one last question we have for you. So we obviously know that you've had like a great journey, you've a solid experience, you've seen a lot of hacks, analyzed a lot of contracts. One favorite vulnerability. I mean, favorite in the sense that you've had some trouble with, or some experience, some funny experience, or any experience with one such vulnerability that you will always remember as long as you audit. We would love for you to share something like that with us.
uh, yeah, sure. I guess I've seen like a number of hacks which were like memorable and interesting as well. So back in the days, I've seen hack getting BZX getting hacked due to like having the double money bug, because it is like you sending money to yourself, and at the end your balance is getting doubled. So that is like a funny and high impact bug. I've seen Cream get hacked a couple of times. I guess they allowed ERC 777 token in a lending market, so they got screwed due to that. They also like suffered a major price manipulation hacks, where I guess there was a Y token of which price was manipulated by the attacker. That was quite a sophisticated and well planned attack. So that was generally a really interesting bug. In the recent times, I've seen like there was a project DFX. They tried to implement flash loans, but didn't introduce a reentrant, non-reentrant guard. So someone like took flash loan from them and then deposited those money again into their protocol. So they got screwed due to that. Uh, a bonk attack was quite funny and interesting as well, because they were reading instant prices from Teller Oracle. So you might be aware that Teller allows anyone to publish prices on uh, like public prices on their feed, right? So if you read instant feed, anyone can submit a fake price, and if you read that instantly, you'll get screwed. That what exactly happened with Bong protocol. So they were, I guess, a lending market and got screwed due to that. And the major one was Euler recently. I guess it was 200 million or something. It was a hard, like, logical bug in their code. If I remember correctly, they didn't have a safety check on in one of their function. The entire protocol was safe. Every check was implemented. There was just one function which was introduced in an upgrade. So that was missing that crucial check, and got hacked due to that. So that was also, you can mention that, an issue introduced by upgradability, or upcoming features. So these are like good hacks, or interesting ones, which anyone trying to be in Web3 security can read about and learn the techniques and methods used by those attackers, so that you can prevent 10 more protocols from getting hacked from the same methods.
Got it. So some very interesting anecdotes and instances, and some of the very recent ones you also shared, Euler, Finance, and Bonk, and all of these DFX. All of these are very recent and very interesting hacks.
Yeah,
So
yeah.
thank you for sharing. Such gems of knowledge with us. It was a very interesting conversation. And thank you again so much for doing this. I'm sure all our viewers out there will thoroughly enjoy and learn from this session. Thank you for being here, Akshay.
Thanks for inviting me, guys. Very happy to be here.
Okay, thank you.
Thank you. Bye.